Good morning, good afternoon, good evening, and welcome to our webinar, Future Pharma, Benefits of Wastewater Evaporation for the Pharma and Cosmetics Industries. My name is Jonathan Haig. I am Head of Marketing at Veolia Water Technologies in Germany, and I will be moderating today's webinar. I hope you can all hear us. I hope you can see our screen. Before we start, I have a couple of admin topics. To avoid any background noise, you're all muted. So if you have any questions, please feel free to use the questions function directly here within GoToWebinar. We have a questions and answer session at the end of the webinar, and we'll try and answer these questions in this session. So with no further ado, it is now my pleasure to pass directly on to our panel of experts who will guide you through today's webinar. Sophie, Manel, Henning, the floor is yours.
Good morning, I am Sophie Lindegaard. I am Innovation Project Manager at Veolia in France, and I am going to talk about the topic of pharmaceutical and cosmetic wastewater.
Hello, everyone. I'm Manel Roca, Sales Manager for Pharma and Cosmetic, based in Spain and Portugal. Thank you for coming.
Good morning, good afternoon, good evening, dear participants. My name is Henning Keutgen. I'm the Director of Business Development for the pharmaceutical industry based out of Germany. And I have the pleasure to begin the session today. I will look at the agenda. So first, a quick introduction, then looking at the industry challenges that you as our customers face. As said, Sophie will look at specifics of the wastewater for pharmaceutical and cosmetics industry. I will get back to the evaporation technology, specifically of Everled, our brand within Veolia Water, before Manel will present 3 distinct case studies of references that we have realized in the last couple of years. And then we come to a short summary and a question and answer session. The webinar should take approximately 40 minutes today, and then we have some time left for the Q&A. So who are we? We represent Veolia Water Technologies, the technology experts within the Veolia group. Sorry, the slide has to move. There we go. Sorry for that. The slide was faster than I wanted it to go. Anyway, so we are Veolia Water Technologies. We are the water treatment experts in the Veolia group. Veolia being the largest environmental services company in the world, with the 3 divisions of energy, waste and wastewater, focusing on the service side, on the operation side. And we, the Veolia Water Technologies, approximately a team strength of 7,700 people globally, serving you, our customers, around the world. Our business is built upon 3 pillars. The first one being technologies and standard packages. So machines, units that are highly standardized and fit the respective needs of the industries, as well as modular technologies coming from technology business units within VWT, Veolia Water Technologies, for more complex flow sheets and larger projects. Accompanying these technologies is a broad range of services. For example, chemicals, anything from flocculants, coagulants, corrosion inhibitors, to a digital service called Hubgrade. We do remote monitoring, remote troubleshooting, to things like predictive maintenance, for example, or building trends for you to have a remote look at how your plant is operating, how it is doing. We do services on our installed base, so anything from repairs, maintenance, audits, over to temporary solutions we call mobile water, treatment technologies mounted in containers, or trailers to be deployed on a temporary basis for emergencies or for planned shutdowns. Our philosophy behind that is a very much global, local approach. So we do have local offices around the world, but are being supported by colleagues from around the world, the experts. So we have access to this expert network within the company. What we can do for the pharmaceutical industry is a broad range of services. So starting at, if you see here, sort of a exemplary production facility from the industry. So starting with a potable water source or a groundwater source, so anything on the influent side, so an influent treatment, for example, to produce processed water, to specific pharmaceutical grade water qualities, the clean utilities, so purified water or water for injection that adheres to all the relevant pharmaceutical guidelines and pharmacopoeias. We have vast experience in reuse, recycling and recovery, optimizing water footprint and usage of water on site. Over to the wastewater treatment side, which is going to be the focus of today's session. Specifically today, looking at fairly small, complex, difficult to treat wastewaters, and as I mentioned earlier, the associated services that go along these systems. And the industry challenges. So what is the motivation why we invited you today to come listen to what we would like to present? These things are the ones that keep you up at night, that guide your business on a daily basis. So on one hand, sorry for that. So on one hand, we have increasing and tighter discharge limits that are imposed on the industry by the governing body, such as the regulators. With that come also potentially emerging pollutants, so pollutants that may have not been on the, let's say, on the list of substances that you have to take care of. So these may be added to the list of substances that you have to control in future, that you have to take care of. If we talk about wastewater treatment of these small complex streams, a typical disposal method or disposal route today is actually incineration. So this is a fairly limited discharge route. It is based on available capacity, on a demand and supply. It is based on cost and also the available locations where you actually can dispose of this type of wastewater. Many companies have ambitious sustainability goals. So this is another driver that makes you that here. Sorry. Yeah. So first we talk about cost. I spoke about cost already. So the discharge is obviously associated to a cost. Then the corporate sustainability goals. So we have customers that have ambitious goals to reduce their carbon footprint. And in comparison to a incineration of such a wastewater, which of course consists of water in the first place, is a very energy intensive and costly process. And lastly, in existing sites, existing production facilities, you are faced with potentially changes in the processes on site. New products are being produced, which means for the wastewater treatment, for example, there may be new streams being added to the wastewater treatment. You may refurbish or upgrade your plant, and this poses challenges for the wastewater treatment plant overall. And in general, the message would be that these challenges will grow in future. So your life will not become easier, and we would like to go further into detail of how we can help you solve these challenges. And with that, I would like to hand over to Sophie to look at the specifics of wastewater, the wastewater characteristics in the pharmaceutical and cosmetics industry.
Thank you, Henning. Now we will go deeper in the topic of wastewater. We will look at the sources of pollution and the challenge of treating this wastewater. Then I will briefly present the evapoconcentration process and the driver for choosing this process to treat your wastewater. These slides show a pharmaceutical manufacturing plant. It has been highly simplified. As you see, yes, thank you, John. The principal contributor is the cleaning of equipment between production batches. The pollutant found in the water depend on the type of the manufacturing plant. For a plant producing chemically synthesized active pharmaceutical ingredient called APIs, you will find reaction residue, but also traces of the APIs in the wastewater stream. If it is a biological processing facility, then remains of the media and buffers used in the biological reactors will find their way into the wastewater along with traces of APIs. In both types of plants, there are processes to extract the APIs that employs metal, solvent, etc. Though most facilities now have technology in place to recover solvent, there will always be traces that find their way through. Part of the wastewater come as well from the scrubbers, treating solvent vapors via the blowdown. For cosmetic industry, wastewater comes primarily from the cleaning and rinsing of the mixing tank after or between the production runs of different products. Okay, what are the challenges in terms of water treatment? The main challenge we are facing with this wastewater is their variability. In the pharmaceutical and cosmetic industry, batch production is still the most widely employed manufacturing technique. It results in big variation in the volume and strength of pollution during the campaign. In addition, some factories produce different products, so the type of pollutant may also change. This is very common for cosmetic manufacturing industry. Wastewater from pharmaceutical industry are also known for being highly concentrated. The presence of high organic content, typically solvent, may further complicate the treatment. In high concentration, they can be toxic for the biomass if biological treatment is considered. Wastewater from cosmetic industry are also very concentrated, especially in the case of hair dye manufacturing. Another challenge is the nature of the organic pollutant. Some of the substances are scarcely biodegradable, so the ability to degrade the wastewater biologically will be very low. Furthermore, presence of metals and high salinity is an issue for biological treatment. Additionally, it increases corrosion. A new challenge is the presence in the wastewater of substances considered as emerging pollutants. Emerging pollutants are substances newly identified as potentially harmful for human health and environment. They are not commonly monitored or regulated in the environment, but mechanisms to identify priority substances for regulation are developed in different zones. In Europe, for example, the watch list reviewed in 2018 includes 3 hormones and 2 antibiotics. As you saw on the previous slide, there are some real challenges for treating wastewater within this industry. Obviously, you need the correct technology to meet the needs. At Veolia Water Technology, we have a portfolio that allows us to meet the majority of these industrial requirements. On these slides, you can see the key technology for primary, biological, and tertiary treatments. We can offer patented technology like ActiFlow and HydraFlow for primary treatment, Anox Calnes MBBR for aerobic treatment, biotain and aerobic treatment. But today, we are focusing on evapoconcentration because it is a chosen technology for complex, problematic, difficult to treat, and small capacity wastewaters. Indeed, it is the most used technology within our 150 references in pharma and cosmetic industry. 40% of our references include an Everled installation. Okay, what is evapoconcentration? The process is based on a natural phenomenon, evaporation. Everled evaporators are industrial systems accelerating the natural evaporation process at low energy consumption. They are operated under vacuum. Evaporation under vacuum allows a low boiling temperature in the system, which reduces the energy requirements. Depending on the technology, our system were either at 40 degrees or 80 degrees. Another benefit for operating at low boiling temperature is to reduce the corrosion, the scaling, and the precipitation in the boiling chamber, which might reduce the performance. Low boiling temperature is also better for handling thermosensitive compounds. Now, if we go more in detail, you see that the whole process consists of evaporation followed by condensation of the vapor. As a result, the solution is divided in two streams, a more concentrated one called the concentrate and a diluted one called the condensate or the distillate. Depending on the achievable concentration factor, we usually get 5 to 10% of concentrate and 90 to 90% of distillate. Depending on the distillate quality and the discharge requirement, the distillate may either be directly discharged to the sewer or further treated before discharge. In some cases, the distillate may be recycled or reused, contributing to zero liquid discharge objectives. As for the concentrate, it's usually disposed of off-site, but a second step of evapoconcentration might be applied for reducing the waste volume to be disposed of. In some specific cases, byproducts are recovered in the concentrate. What is the performance? What are the results? On one side, we have a concentrate which contains the pollutant having a boiling temperature higher than water, like metal, ions, oils, surfactant, and volatile organic compound. On the other side, we have a high-quality distillate made of low-conductivity water and organic compound having a boiling temperature lower than water. In the picture, you can see the sample of a lab test for cosmetic wastewater. On the left, you have the feed water. On the right, you have the concentrate. And in the middle, you have the distillate. You can notice that the distillate looks like distilled water. Concerning the performance on pollutant removal, we have the following reduction rate. Minerals and metals are almost completely removed, 90 to 98%. We obtain a very good reduction of organic pollution, COD and BOD, as far as organic compounds are not volatile. Concerning micropollutants, for example, the APIs, the performance depends on the API itself, its molecular weight, and the applied temperature in the boiling chamber. Okay, here are the drivers specifically related to the wastewater quality and quantity. If we talk about the wastewater streams, segregation of specific stream is frequent in this industry. Highly concentrated, toxic stream and difficult to degrade streams may be singled out for a specific treatment to reduce their toxicity and volume. Evapoconcentration is perfectly suitable to treat these wastewaters. Another driver we see more and more frequently is micropollutant reduction. For example, APIs in pharma wastewater. Some API containing stream may be better handled separately from the main wastewater treatment plant. This is of interest, particularly where the bulk of wastewater does not contain APIs, as it avoids the cost of treating the full volume of wastewater with micropollutant removal technologies. In recent years, we have proposed many Everled installations with API reduction targets. Third driver is the relatively small volume of wastewater. In some site or workshop, the daily volume of wastewater produced is very low, 1, 5, 10 cubic meters a day. For such small capacity, A treatment including a conventional treatment with biological treatment might be difficult to consider. At last, a frequent application we have for this technology is a treatment of wastewater coming from compendial and utility water production, ultrafiltration, reverse osmosis concentrate, ion exchange regeneration. The beauty of evapoconcentration is that this process is able to address these four problems in one unique treatment. This is all for the topic of wastewater, so I will hand over to Henning, who is going to present the Everled evaporation technology. Thank you for your attention.
Thank you, Sophie. Yeah, so the next few slides will focus on the on Everled and their packaged systems. Everled being a technology business unit under the roof of Veolia Water Technology, so 100% subsidiary of Veolia Water Technologies. Everled having their headquarter in Zoppola in Italy, and also the workshop where these machines are being built. And well, since 1999, Everled is actually a part of Veolia. So the three different types of units that we have in our portfolio. Here you can see these three different types. The models are differentiated by several factors. So one of them is the mode of heat transfer. So the PC type functioning with a sort of the heat pump principle. The AC type with a hot-cold water, often used on cogeneration sites, for example, where hot water may be available, and the RV type, the mechanical vapor recompression type. So these the three different models, actually one of the, let's say, broadest portfolios on the evaporator market. The heat transfer, as I mentioned, is one. The other difference between these machines is the evaporation temperature. So the PC type, for example, operating at a fairly low temperature of around 35 to 40 degrees, and also the concentration factor. So basically with every type of wastewater that we would be faced with, we have a large range of machines to choose from to basically fit your needs ideally. They of course come in different sizes as well. I will look at that in the next slide. And another important feature is as well that they can be produced in different materials of construction, which could be, necessary based on the corrosion, for example, of the water. So it could be that the evaporation chamber is built not in stainless steel, but in super duplex. So this is really looked at on a case-by-case basis. But within the standardized package approach, there's a large range of flexibility to really suit every need. Often these machines are also used in combination. We will also see that in one of the references that Manel will show. So it could be a first stage evaporation, and the concentrate from this first stage could be treated again in a second stage. Specifically for these high concentration applications, there's a special model with a kind of a scraper to actually reach concentration levels which are close to crystallization. So you really get very, very high concentration levels to minimize that volume of concentrate, the concentrate being the part that contains the substances that you actually want to remove. So the key points for the Everled evaporators, again, so they are tailored at complex small streams. I mentioned the flexible use, so we can go from anything from 0.1 tons a day to approximately 120. This is per unit. So on the top right here, you see a picture with 4 units working together. So of course, this 120 is the limit per unit and can be increased by adding more units to this. Sophie showed the picture with the high separation levels. So you see really the water in the middle looks like clean water, and the concentrate on the right being the one with all the impurities that you want to remove. this system, or the evaporation, is often also used in zero liquid discharge process flows. So when the goal is to not produce any liquid leaving the factory, evaporation is a key technology to achieve this ZLD. One thing that is another application next to actually the disposal, or to collect impurities in the concentrate, could also be to actually collect things we want to recover in the concentrate. So this is also possible, but based on our references, this is the, let's say, the lesser case. The majority of references we have actually are for reducing the disposal volume and cost. Comparing the technology to incineration means obviously that there's a much lower energy consumption, because the vast amount of water is removed. And yes, as we said, these units come as modular units, so it's kind of a plug and play approach. You can add it to your existing systems or standalone. This is also going to be shown in the next slide. The units are fully automatic. I mentioned Hubgrade, the remote monitoring, and of course the factory and the manufacturing adheres to all latest quality regulations like the ISO 9001. The two typical cases of how this system can be implemented within your operation. So one, it could be a part of a larger, more complex flow sheet, kind of the end of pipe solution at the very end of the treatment process. For example, you may collect concentrates from an RO already, and these already sort of waste streams could be collected together and then treated with an evaporator for the final step. So we call it as unit operation in this larger complex flow sheet. The other one is a standalone unit for a segregated stream, potentially with a simple pre-treatment or post-treatment for the distillate, but it is a very much standalone unit that can, basically you hook it up, like I said, sort of a plug and play. You hook it up with the influent on one side and the distillate and concentrate outlet on the other, connect power, and then this unit can work very much by itself. Accompanying these units are the services specifically tailored to Everled. So anything from maintenance, service, spare parts, revamping or repairing existing plants, over to the Hubgrade, the digital side, so remote monitoring, remote troubleshooting, and we also do audits or consulting. So this is allows you a hassle-free operation for many years to come. So we just want to make sure that the units are, that the units are serviced. Now, one very important topic today is, of course, how does this all fit in with the cost reduction we spoke about? And we took some figures. We collected information from several references from Europe, and here you can see kind of a exemplary example of how fast actually the payback is for such an installation. So we have some assumptions on the left side here. You see it is a wastewater volume of around 8,000 tons a year, a distillation rate of 92%. We assumed electricity or energy cost of 12 cents a kilowatt hour, and the evaporator energy consumption 50 kilowatt hour per ton of wastewater treated. And you see on the right side, in comparison to a typical off-site disposal cost, which is comprised of the transportation as well as the actual disposal fee, depending on how high this is. So typically you would truck this wastewater off-site for treatment. You see that the payoff in years is well, for these examples where we start with 150 euros a ton, the payback is less than a year. So these units really, the investment into these units really pays back very fast through the mentioned reduction in the concentrate, or the reduction in volume to concentrate these impurities that actually are the key to remove, and just separating the water from it. All right. And now I will hand over to Manel who will present 3 distinct references. Yeah, thank you.
Thank you, Henning, for your explanation. Now, I'm going to show 3 interesting case studies in pharma, cosmetic, and healthcare industry. Okay. First one, case study number 1. Let's start by healthcare in Spain. More concretely, is the case study of 2 hospitals. First one is Galdacao Hospital at the north, and the other one is Ramón y Cajal, one of the biggest hospital in Spain. In both cases, the main driver was the disposal cost reduction of the sanitary chemical waste. According to Spanish legislation, these waste have to dispose by specialized company because it comes from dangerous waste, blood, chemical products used for the analytical. Okay, this solution allows both clients reduce the total dangerous waste, so the invoice of disposal cost is around 80%. Okay, it's an important reduce. In addition to this important economic driver, they also been able to implement a more sustainable treatment, considering that the distillate could be reused for other utilities. Finally, this solution, can you see, is safer and secure because have less manipulation of the people in this case and reduce of waste plastics. You can see the pictures of the installations. Okay, you can see the compact system into the installation. In both cases, the equipment proposed has been the same PC model, the heat pump evaporator with a capacity of production by 700 liters per day. In the case of Galdacao, the Veolia water technology is running an all-impact solution. It means pay-per-use. As Henning said, 1 more capability of our service in Veolia. All-impact means a complete solution, including the supply, installation, startup, and 24/7 maintenance contract, including consumables, all spare parts with a upgrade digital service, online control. Very important to check and to monitoring the all installation. All of this with the guarantee by contract of the quantity and quality of the distillate, so the client has not to worry about this installation. Okay, you can see both equipments into the installation in right picture and up. Important at last, but not at least, it's important to point out the short payback was achieved less than 6 months. This was a very important driver too. The second case is a world-leading pharmaceutical company located in Germany. In this case, the client also wants to reduce the high waste disposal cost from incineration. This waste could not be treated in the wastewater treatment plant. So a combination of drivers was to implement a more suitable management to meet with specific local limits, achieving the operational goals in terms of sustainability and environmental footprint, which is very important for the client. In this case, the best technical solution for this project was RVF model, a mechanical vapor recompression evaporator with forced circulation. This range of equipment of product is designed to treat large daily volume with low energy consumption and high efficiency. You can see too the picture, a very compact and modular design system integrated at site. Another benefit was the client was able to continuous production because don't fill up the wastewater tank, as well as reduce wastewater logistics and lower personal cost. Important too, equivalent CO2 reduction. The number 3, case study number 3, is a very important cosmetic industry in Italy. We have chosen this case study because it's an important reference in Italy for the production of creams, shampoos, and other cosmetic products. The client also wanted to segregate the one stream coming from the rainwater of shampoo production, since it caused a lot of foaming problems in the biological NBR waste treatment plant. The solution that we will show you allow the client to reduce operational costs of the wastewater treatment plant and reduce the production of sludge. The presence of surfactants, you can see the last sentence, is the main case of foam issues in wastewater treatment plants, in particular in the biological tanks where the foam formation is amplified by aeration. You can see a general flow diagram from the installation. In this case, our solution provided by Veolia consists in a pre-treated with 2 different equipments before biological plant. You can see on the left system RV, and the right Everled AC. The first evaporator, in this case, it's a mechanical vapor recompression that treats 30 tons per day. The distillate is sent to NBR plant, which is diluted with the rest of the effluent to reduce concentrations of the contaminants. The concentrate of this unit is mixed with a second stream and feed a hot water vacuum evaporator, AC model. The distillate is also sent to NBR plant, while the concentrate is sent to final incineration. In this case, the treated effluent is sent to discharge with strict compliance with the local regulation. So this techno solution allows a concentration factor around 10 in relation to the inlet effluent. Okay, so reducing the production of sludge in the biological plant, the operational cost of running NBR plant, and reducing final cost of incineration. Also indicate the reuse of the water treat on the membrane bioreactor. It means NBR produce a high quality water which can be reused for irrigation or industrial needs, floor washing, etc. In the table, you can see that high concentration surfactants in the feed water has been totally removed in the distillate. So in the right picture, you can note the compact, modular, and easy to the site installation. Important, finally, the payback of this project was achieved in only 10 months. Okay, just to finish, it's a very short case study and to treat a general review from application. Everled has more than 3,500 references worldwide. Here you can see a short list selection of the last reference in pharma, cosmetic industry in the last 3 years. API applications, cream and lotions, pharma applications, etc. would be the normal for that. Okay, thank you. Thank you very much.
Okay, thank you, Manel, for presenting the references. And I have the pleasure now to do a quick recap, a summary of what we discussed today. Yeah, why is evaporation technology the technology of choice? So we have we saw the concentration levels, so up to 95% in combination, two machines in combination, even up to 99. There we go, up to 95 or in combination, even up to 99% reduction in the disposal volume. This just has several key advantages. So it is not only, let's say, cost in disposal, transportation, it also has an effect on, for example, storage and handling on site. It has to do with safety. You can imagine if you have to handle 100 IBCs with wastewater versus only 10, this does make life much easier. So it is one of the key factors that benefits this technology. It helps companies reach sustainability goals by really going into the ZLD, into ZLD. So you have no liquid discharges anymore. So the liquid that would have typically left the site to go to incineration is concentrated up. So this is one of the other key benefits of this. The design of the machines, these machines have been built for several years, for 20, 30 odd years. So constantly optimized. Manel spoke of the forced circulation, for example. So the design overall of these machines is tried and tested and focuses on high efficiency and high concentration. You saw also the pictures of the reference plants. These machines are kind of a plug and play, container-like for the bigger ones, and for the smaller ones, skid mounted. So they're easy to integrate, fast to integrate, simple to integrate. So this makes it very easy for you as a potential user. The evaporation at low temperature also opens up a host of applications that are would not be attractive if we would only evaporate at high temperature. So we have the flexibility between the evaporation temperatures and the machines. And last but not least, and one of the key things, of course, for an operator or for a customer, is that it makes economical sense. So really these machines make sense, and depending on the disposal cost that we saw earlier, and these disposal costs are high and getting higher all across of Europe. This really pays back very fast. And if basically you know that you're still sending truckloads of wastewater to incineration, then this would be something that you can come talk to us. So with that, I would like to say sincere thank you to all listeners, to all participants, in the name of the three presenters, Sophie, Manel, and myself. And I will hand back to Jonathan. Thank you.
Thank you, Henning. Thank you, Sophie. Thank you, Manel, for your presentation. Before we move on to the couple of questions which have come up, just wanted to go one more thing, which is just have a quick look at the AKIMA Pulse, which is coming into focus next week. A number of you may well know the AKIMA exhibition. This year, due to Corona, the AKIMA is happening as a digital event for the process industry. We as Veolia Water Technologies will be taking place in the exhibitor channels, as well as a session in the Congress conference. And there are a couple of things which are interesting. The one topic is obviously at the top, you can see happening on the 15th of June, Tuesday the 15th of June at 14:30. We have a channel also looking at Everled evaporation in the pharma and veterinary wastewater. Along with a number of other topics which Sophie mentioned today. A number of our solutions and services will be covered, including on the right-hand Wednesday, the 6th 16th of June at 10:40, we will be going into detail about our Hubgrade digital services. So this is something which could be interesting. We have a number of free tickets available. So if you're interested in visiting us, listening to these sessions, please contact us to get a free ticket. So moving on to the questions and answer session. As I said, we have a couple of questions, and if you guys have any more, please feel free to use the question block which is available. I'm going to start with one that I've got here, which was asking what are the pre-treatments required prior to the evaporation. Sophie, maybe you can answer this one.
Yes, of course. Well, pretreatment, it depends on the wastewater pollutant present, the pollutant present in the wastewater. Usually, screening is recommended to prevent from troubleshooting in the valves, equipment, etc. And then eventually, depending if there is free oil of or sedimentation solid that can be easily removed, it is recommended to remove them before the evapoconcentration. It will improve the performance and won't give so many trouble with scaling and fooling of the machine. But it will be evaluated on a case by case basis.
Okay, then I have another question which has come in. Maybe this is also part of the question which you can answer, or Henning, which is are VOC present at the distillation stream? If not, how is this process success or removed from distillate?
Well, the volatile organic compounds, if they are present in the feed water, they will go in the distillate. So this has to be, we can't take off, stay them in the concentrate. So usually, if when we do our lab test before to assess the feasibility of the process, we will see what the result is in the distillate. And if there are too many VOC, it will be a no-go. It means that the industry should maybe has a process to distillate, a distillation process in the site itself.
Okay, good. Thank you very much. Okay, something maybe then I have a question for either for Henning or for Manel, which has just come in. Which products within the cosmetics industry will produce the most complex wastewater streams?
Well, I can answer a little bit for my. I know that, for example, for cosmetic industry, there is the manufacturing of air dye. It's a really complex, very concentrated wastewater, and it's difficult to treat them by other technology. So we have experience with air dye on evapoconcentration, and it gives real good results. If we talk about pharma, it's so variable from one side to another. So it's difficult to say. There is no standard rule for that.
Okay, great, thank you. Then I have another question which has come in at Henning. What are the power consumptions? Sorry, what are the power consumptions for the process?
Yeah. So we talked about the different mode of heat transfer to the devices. And if we remember, so we had the heat pump model. So these are typically in the range of around 150 kilowatt hours per ton of wastewater treated. The AC model, so the one that is operated with hot and cold water, these machines actually work in stages. So we do have sort of a 1-stage or a 2-stage process. The 1-stage process is the most energy intensive with approximately 700 kilowatt hours per ton. The 2-stage process is around 380, and the mechanical vapor recompression machine is typically in the range of around 35 to 60 kilowatt hour per ton of wastewater. So of course, let's say compared to other wastewater processes, this is a larger energy consumption. But again, we have to compare it with the typical way of otherwise removing this wastewater, which is incineration. And compared to that, based on the curve I showed and the payback, the energy consumption is of course factored into this, and it still is a much better energy balance overall.
Okay, great, thank you. There are a few more questions which have come in. I have a question here. Can wastewater with ATEX, also ATEX products, be treated?
Sophie? Yeah, please.
Henning, please, you.
The machines do not come in a the machines do not come with an ATEX certificate, correct? So they can't be located in an ATEX area. If you talk about ATEX relevant substances in the wastewater, I would assume this applies similarly. So this would probably be not possible. Do you agree, Sophie?
Yes, I agree fully. Yeah.
Yeah.
Okay, thank you very much. Then I have we can squeeze in one last question now. Does the distillate water has a high grade quality to be reused for production of chemical products? I don't quite see the question there. In that one, I'm just reading through one of them because I see that.
Sorry. Of course, it depends as well on the wastewater, the field water. So if you don't have any volatile organic compound, you will get a distillate with very low COD and no TSS, no metals, so it could be directly reused, but usually it could also require a post-treatment like activated carbon filtration or reverse osmosis to be sure you have the right requirement with the right quality. It depends on of course, the wastewater quality and as well as the requirement on the application.
And
okay,
maybe to add to that briefly, if we just have 30 more seconds. So I think the key driver is not necessarily the reuse, but we have several examples where this was added, let's say, as an added benefit. Manel's case study showed that the distillate goes on to an MBR. So this could, an MBR treated water, typically free of TSS and high quality, could be reused on site. So especially also in a ZLD concept, the reuse of the distillate is always a factor that is considered.
Okay, great. Thank you very much. There have been a number of other questions which have come in, more than we can actually deal with now. I appreciate all of these questions. We will get back to you, and your local person will get back to you, try and answer these questions that you have asked us as soon as possible. You will get the recording from today afterwards, so this recording will be sent to you. You will receive this by tomorrow at the latest. We would like to thank you all for participating today. Thank you from my side to Sophie, to Henning and Manel for all of your support and for your presentation today. And I wish you all a very, very good day. and enjoy yourselves. Thank you and goodbye.
Goodbye.
Goodbye.